Hi everyone. Today I'm joined by Sune Karlsson, professor in statistics at Örebro University and also the author behind multiple articles related to variable selection. A short introduction to the topic is that we often meet clients who just recently started looking into which external factors impact their market or revenues. And they often start with a very simple Excel exercise looking into which factors correlate with their market or revenues, especially with a lagged correlation. So it's fantastic to have you here, Sune, to bring us more knowledge into this topic. Very welcome.
Thank you.
If you're comparing correlation to more advanced variable selection methodologies, what would you say is the main difference?
The main difference is that the correlations just look at one variable at a time, and in a linear fashion as well, not taking account of possible non-linearities in the relationships. But most importantly is that it's just one variable at a time. It doesn't take account of the effect that other variables might have on forecast performance or predictive ability. So when building a forecasting model, you really need to take account of how different variables interact with each other, and how, when you explain something, part of the outcome you're interested in with one variable, the next question is not how much does other variables correlate with what you want to forecast, but how do they correlate or interact with the things you haven't explained yet. And that you can't see by just looking at simple correlations. You need more advanced method that can look at several variables at a time.
Okay, so they have kind of a group effect, you could say, on the...
Yes, so it's how variables jointly help predict sales or prices or whatever we're interested in forecasting. And we need to look out of sample as well, not just in sample, in order to really say something about predictive ability.
Yeah, I guess that's a great topic to explore, the out of sample improvement, because that's what you're looking for with a forecasting model. And looking more into like the details of the correlation, let's say that you would have run 1 million data set looking at correlation to your sales or market data. What's kind of what's the downside of that approach?
Well, the downside is that you find single indicators that might be good. I mean, correlations are not useless. they have information, but what we're interested in is to find the set of variables that gives the best predictive performance. And just looking at one variable at a time, which correlations do, we find that, okay, variable X is most highly correlated with our target. But that doesn't mean that variables Y and Z together might, or even do they, by each one of them has a lower correlation. Together, they can give a better forecast performance than what just X does. So it's really how variables together combine information about the thing we're interested in.
You could almost say that you're looking for where the variables are competing towards each other, and also how they, in a group, brings accuracy to the forecast, I guess.
Yeah, and looking at just correlations, you might find that the two most highly correlated variables are themselves strongly correlated. Then including both of them doesn't really improve things very much since they have the same information. What we want to have is to find the other variables that brings unique information that isn't in the other variables. That gives added predictive information. And for that, we need to have methods that look at collections of variables and different mixes of variables and compare them.
Very interesting. Another aspect is the funny correlation, or also referred to as spurious correlation, that you can have two variables with a very high correlation but doesn't have the causal relationship. Is that something that a more advanced variable selection methodology handles?
Not necessarily by itself. I mean, there you really need to reason about things as well. Is this a sensible variable that well, I don't have a good example right now. But the two variables are highly correlated, or even that they appear to have a good forecasting performance. Of course, that might be completely spurious. And rainfall in Brazil and sales of a product in Germany obviously are not related, but they can just look very similar in the data. And there, I mean, one thing that does help is to actually do a predictive exercise where you do simulated auto-sample forecasts and see if a relationship you find in sample holds up out of sample. That's a useful exercise that can help with this, but you also have to use some amount of common sense also.
That's often my advice as well, like looking at millions of data sets and how they correlate. It's not going to give the right answer to the question because it might be that it doesn't make sense. It could be just a funny correlation. So instead, pick those variables that you feel make sense and then bring them into an advanced variable selection methodology.
Yeah, that's what I would do as well. I mean, you need to think about the variables, but of course you can try some stuff, but then you have to think about, is this really meaningful or not?
Great. Thank you so much for bringing some knowledge into this discussion.
Okay, it was a pleasure.